Hi, welcome back. In this session, we are going to discuss about different methods to create NumPy arrays. So the first one is range function that is very similar to the range function in Python. So it has a start point and end point, and we will create a continuous numbers in between these 2 points. So we will see how we can write in the actual code. So I'm writing np.range function. Then the start point I'm giving 0 and the end point I'm giving 10. So output will be 0 up to 9, a continuous numbers. Or if we can create np dot range 15 to 35. So it will give a one dimensional number array 15 to 34, a continuous number. Suppose I don't want a continuous number. Instead of I want a step like 15. After 15 it become, instead of 16 I want 17, then 19, then 21. That means the step is 2. So we can give np dot range. First we will give the range function 15 to 35. Then we will give the step. So I'm giving the step 2. So now 15, 17, 19, 21. So this is a step for that. So the next is the third or fourth option in the NumPy range function is np dot. Here actually the output is in an integer format. Suppose we want to give a float, we want to get the output in a float format. So that is a fourth function, np dot range. So the starting is 15, 35. So I got a continuous one dimensional, continuous numbers one dimensional array, and then I'm giving a step of 3, sorry, and bracket here. So I got a step of 3 up to 33. Now now it is an integer format, the output. Now I want a float. Then what I had to do, d type or data type equals float, then close the parenthesis. So the output will be a comma there, sorry, in a float format. That is all about. Now the next is, as suppose if I'm giving np dot range, I'm giving only one output. For example, I'm giving only 15. So what will be the output? Is sorry, one input. So output will be it, the 15 it will taken as the last, like the end point, and the start point will be taken 0, or the start point will be by default 0 and the end point will be 15. So if you are giving only one digit. And also there is one more method to create the data type float is np dot range. Start point is 0 up to 15 and the indexing is 2. So if I'm running this, we get everything in a int format. If I want everything in float format, we can give the or the step in float format. So if I'm giving 2.0 the step, we will get it in a float format. So that is all about range function. And one important thing is range function creates only a one dimensional number array. Next is that we how to convert this one dimensional number array into a two dimensional number array. So this is the range function NumPy array we created. For example, np dot range 0 to 18 I'm creating. So it is the same one dimension NumPy array. Now the next command is reshape and resize. Using that we can convert this one dimensional array into a two dimensional or even three dimensional or four dimensional, any dimension. So here I'm showing an example how to create that into a two dimensional NumPy array, that is with shape 6 or 6 rows and 3 columns. So the command is, first I am creating this NumPy array np dot range function one dimensional array. Now I am assigning that to a variable x. So x equal to this one. So if I am checking the value of x, x is nothing but a NumPy array of one dimension. Now I'm converting this x into a three dimension like this in the picture. So the formula is, or the code is, x dot reshape, and I will give the shape, that means 6 comma 3. That is the shape I want to replace, and x is nothing but the NumPy array we have created. So now the 0 to 17 is converted into a two-dimensional NumPy array with the shape 6 by 3 or 6 rows and 3 columns. Suppose I want to create it into a three-dimensional NumPy array. So we can create x dot reshape 3 by 3 by 3 by 2. So I created into a three-dimensional NumPy array. So it will become created into a three-layer NumPy array, 3 layers, and in 3 rows and 2 columns. It's created into a 3-dimensional NumPy array. And also one thing, important thing is that the elements, number of elements in the reshaped and the number of elements in the actual NumPy array should be same. For example, here we have 18 elements. So the 2-dimensional or 3-dimensional we are creating should have only 18 elements. It should not be less or more. Let's have a look what how it is if you are giving a different value. For example, I'm reshaping it into 6 by 4. That means the elements it should have is 24, but we only have 18 elements, so it will give an error. Suppose I am taking into 3 by 3, that means only 9 elements, less element, that also will not be able to create. So it should be 6 by 3 or 3 by 6 also we can try. 3 by 6, it will give 3 rows and 6 columns. That is all about reshape. Now next we will discuss about resize. So before going to resize, I just want to discuss one more thing. So I created a NumPy array X. Now I am the next comment here. I am reshape it into a different size, that is 3 by 6. Now I am again checking what the value of X, what's in X. So if I'm checking X, X is still that previous or original one-dimensional array. That means this is not overwriting it. It's just giving a showing the output, but it's not overwriting the original X. So original X is still the one-dimensional array, because the step is we can see we created the one-dimensional array here and we use the reshape command to reshape it by 3 by 6. And again, if I'm checking X, X is still the original array. That means reshape is not actually changing the original array. But there is the next command is called resize. For example, similarly, I'm using resize here. X dot resize 3 by 6. So I'm using the resize command. And now I run the resize command here and I'm checking the value, what is in X. So now if I am seeing X is actually got replaced with the newly created array or the newly reshaped array. So the difference is reshape and resize. Reshape will not convert or change the original array, but the resize will override the original array. That is the difference, but the functions are both are same. So we can use reshape and resize to convert it, but reshape will not change the original array, but resize will override the original array here. So the next is random. Random is nothing but we can directly create a 3-dimensional or 2-dimensional, any n-dimensional array with a random numbers. So the formula is very straightforward. np.random rand int means the output will be an integer and it's a range 0 to 10. So we need a range 0 to 10. So within 0 and 10, it will pick random numbers, any random numbers. And this, the next is will be the shape of the NumPy array we want to create. So here I created a random numbers between 0 and 10 with the shape 5 by 3. That means 5 rows and 3 columns. Suppose same thing I am creating with a different. Suppose instead of 10, I am putting 100 and I am giving a different shape like 3 by 10. So it has 3 rows, 10 columns, but the random numbers will be in between 0 and 100. So the output here will be a integer number. Suppose I want like a float number, so we can use np.random.uniform. So the same function, but the output will be a float. So here we created a random numbers, float random numbers between 0 and 10, and the shape we need, the output is 4 by 3. Also we can create a 3-dimensional matrix also. If you create a 4 by 3 by 3, it will create a 3-dimensional matrix. Any dimensional matrix we can create. For to make it understand or make it simple, I created a 2-dimensional matrix here. Now the next is linspace. Linspace is nothing but we can give two range and the number of equidistance we need. That means 0 to 15. I need 4 numbers in between 0 and 15, including the 0 and 15. That means the start point and end point. So if we run this, we can see that there are 4 digits created with equidistance. That means 0 to 5. So difference is 5. Again, it increased to 5. So 5 to 10 and 10 to 15. Similarly, if you can use np.linspace, I'm using 0 to 10, 3 digits. So what will happen? 0, 5 and 10. That means only three equidistant numbers will created between 0 and 10. Or we can create even float also. 0 between 0 and 5. I am giving 20. The 20 equidistant points will get created here in linspace. So that is linspace. The next is zeros. So zeros is nothing but it will just create zeros, but we will give the shape of the NumPy array. So np.zeros, the formula is np.zeros, open the parenthesis shape, and what shape we need equals to 3 by 4. So all the elements will be 0, but the shape what we given is 3 by 4 that will get created. Instead of 3 by 4, if I want to create 3 by 10, so the NumPy array of 3 by 10, that is 3 rows and 10 columns, but all the elements will be 0. That is np.0. Next is ones, that is very similar to 0 only, but only difference is that the 1 will create. Instead of 0, it will be 1. So here I created a three-dimensional NumPy array. Instead of I am just changing that to, so np.ones comma open the parenthesis shape equals 2 and 3. So it will get created once. So and a data type also we can give np.int16. So any data type we can give here. So this is once, and next is I is nothing but if you run this, it will give all a 4 by 4 matrix, but with the diagonal elements 1. That means all the diagonal elements 1. So if I am creating instead of 4, I am creating 3, np.I3, it will create a 3 by 3 matrix, a two-dimensional matrix with the diagonal elements 1, that is I. Next is diag function. So for diag function, we need to create a one-dimensional NumPy array first. So I have created a one-dimensional NumPy array here with the element 4, 5, and 10. That means there are three elements now, and assigned to a variable y here. And when I'm passing that variable or the y or the NumPy array to a function diag, that means np.diag of y, what it will create? It created a square matrix with the size of the one-dimensional NumPy array. That means 3 by 3 here. That means there are three elements here, and 3 by 3 matrix it will create a square matrix, and all the elements will be 0 except the diagonal, and diagonal elements will be replaced with the elements here which we passed. So that means here 4, 5, 10. So the diagonal elements will be 4, 5, and 10, and it is a 3 by 3 matrix. On all other elements will be 0. Similarly, if I am creating a bigger NumPy array, like it has 5 elements, 4, 5, 6, 10, and 20, and I am passing that to a function diagram, np.dia. So here it created a 5-dimensional 5 by 5 square matrix with the diagonal elements will be 4, 5, 6, 10, and 20. That means these elements which we already passed. So the next is empty. Empty is nothing but it just created a 0-bit elements with the NumPy array. So the 0-bit elements in the NumPy array, and it is the shape of what we had given. So here I am given 2 and 3. So the shape will be 2 rows and 3 columns, and empty got created. Empty NumPy array got created here. And the next is a repeat. Repeat is nothing but, for example, if I have a few elements like 1 and 2 and 3, and if I am running this command, what it does, this element after the comma what we have given, that much time it will repeat. For example, the first element it will repeat 3 times, then the second element it will repeat 3 times, and the third element repeat 3 times. Suppose instead of 3 I am giving 5. So what will happen? Those elements will repeat 5 times. Or if I can increase the number of elements 5 and 6. So those elements also got included, and it will repeat 5 times. That is repeat. So these are the basic methods of creating NumPy arrays in NumPy, but we can combine these methods and other methods together, and we can create a complex NumPy arrays in NumPy.